Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello and welcome to another episode of CTDS.Show, the show bringing you quarantine content, having interviews with my machine learning heroes. In this episode, I interview senior data scientist at H2O.ai, Kaggle competitions master, and PhD holder in mathematical physics, Dr. Dr. Maximilian Jeblick. We talk about his transition from physics into data science. Max draws many parallels between the two and how the terms used, even in his research, show a really nice parallel with data science. We discuss about his experience of teaming up with the oldest Kaggle grandmaster, Dieter, Christoph Henkel, and Max shares his advices and his learnings from competing on so many Kaggle competitions and how should you, go about learning from a competition while also trying to take part in it and slowly moving up the leaderboard over time as you keep competing in these competitions. We also discuss Max's work at H2O.ai, and he also shares advices around how can you balance all of these amazing things that he's contributing to work, Kaggle, and data science, broadly speaking. For now, here's the conversation. Please enjoy the show. Hi everyone, today I'm excited to be talking to another maker, Dr. Max Jeblick. Max, thank you so much for joining me on the podcast.
Yeah, thank you. It's an honor to be on your podcast.
It's an honor to be talking to you.
Thank you.
So I'm going to talk a lot about different things about your background, but I want to start about talking how you transitioned from physics and maths into data science, I believe. What was the factor driving that transition for you?
I think there were about maybe 3 factors for doing so. So maybe to give you some background, I will explain what I did during my PhD. So I studied physics in Munich at Ludwig Maximilian's University. I also did my PhD in mathematical physics. And what I was looking at was the dynamical description of quantum gases. So imagine you have a metal, you cool it down to very low temperatures. Then at some point, you will observe superconductivity, which means that you don't have any resistance any longer. You may notice videos where you have a superconductor and on top of it, you have a magnet floating, which is quite some cool phenomena. And that you can explain with quantum mechanics. So it's a quantum mechanical phenomena. And also you have the same with superfluidity, for example. So with liquid helium, you cool it down, then at some threshold, you will observe that you don't have any resistance any longer, so no friction. And you have a superfluid. And what I was looking at is a so-called Bose-Einstein condensate. So you have a dilute gas of atoms. You cool it down to almost absolute 0 Kelvin. And what you then observe is that you get a state of matter, a so-called Bose-Einstein condensate, which means that almost all particles are in the same quantum state, which is quite amazing, I think. So it's really an interesting state of matter. And this state of matter is very fragile. So if you disturb it a little bit, you destroy the condensate. If you shine light on it, you destroy it. So what you really want to understand from a theoretical point of view is what are the properties of this condensate? When will it collapse? When won't it collapse? So depending on the physical parameters, how will the condensate behave? And in particular, what I did And this is interesting with regard to data science. So what I was looking at is an error function, a loss function, and the loss function describes the relative number of particles which are not in the condensate. So you have the loss function. Initially, you're in a Bose-Einstein condensate. You observe the time evolution of that gas, and you want to show if initially the loss function is small, then at some later times, under some assumptions about the physics of that system, the loss function is still small. And so what I did to show this is that you have the loss function depending on time. You take the time derivative of that, so the gradient, you get a bunch of terms, and you estimate these terms and show that these terms are small. So it's like,
were these terms similar like data science, since like we already know about gradient, some of the audience that is from data science, are the same terms used in physics as well?
Yeah, it was very similar actually. So what was interesting, and this was, I think, a striking moment for me, is that the loss function I was using, so you have the loss function, you show it small, then show the gradients are small, which implies at some later time the loss function will be small. And the loss function I was using, so I was reading this paper about object detection and where you detect objects with masks. And they use, in that paper, they propose a loss function called focal loss, which they then show they had some very nice properties which helped the neural network to converge better. And I realized, oh, that loss function, or the idea behind it, was very similar to the loss function I was using, because I had to tweak the loss function quite a bit to be able to show that the gradients are small. And the way I used it in my PhD was very similar to this focal loss idea, which is a modification of log loss.
Okay.
And this was amazing for me. So I saw so many parallels there. So what I was doing on pen and paper, interestingly, to how machine learning, data science, and deep learning work. Because at the end, both are like optimization problems. Even if you cool down the condensate, you try to bring it to minimum energy. So that's another minimization problem. So I was working a lot with these minimization problems, with the loss functions, and so on. And this was one driving factor for me, really, to go into data science.
Okay. Bose-Einstein condensate it's a very volatile state, like you mentioned. So were all of these theoretical calculations, or did you like actually produce that condensate and then collect the data? What tools were you using for all of the data analysis, if I may call it that?
It was purely theoretical.
Okay.
So in Munich there's a laboratory, which are very renowned scientists, and they're able to produce them, but it's really hard, so I wouldn't be able to do that. So it was really based on the theoretical part, on the mathematical description of that condensate.
And were you using NumPy, Pandas, all of these libraries, or was this more
really
on the MATLAB side?
Calculations.
Okay. Awesome.
So, yeah, kind of different. I think another factor which drove me into data science then was also, if you want to get a permanent position in academia, it's pretty hard to do so, because you need to, so after your PhD, you need to do 2 or 3 postdocs. You have to move around, go to different cities. You need to apply every 1 or 2 years for another position. And then there are very talented people in that field. And the number of open positions which are permanent is rather limited. So you have to be willing to go all in with that.
Certainly. So you transitioned from your traditional path that you talked about in academia to industry. You actually, I think, joined a startup first. You founded a startup. How was that experience? Any good memories from that?
It was really amazing. So what I did, after the PhD, I co-founded Kumbu.ai. So to give you some background, Kumbu is a valley near the Mount Everest. Therefore, the name comes from. And we were 4 people in total. So there were Christoph, aka Dieter, you may know him.
The retired construction Kaggle grandmaster.
Did the construction work. And then we were 4 people in total. There were Hannes and Philip. They were all from my research group. So we co-founded this together, which was quite interesting, an interesting experience. And I think the key insight I had there is like, really do what you love. So we love doing Kaggle competitions, we love data science, and it was really amazing to be able to transfer the knowledge you gain inside Kaggle to a customer project. So we were doing customer-facing data scientist. And it was also really interesting for me to see how the businesses work. So the business might come to you and say, hey, we have some fraud from our customers. What are the measures we can reduce this fraud? So it's not about, hey, we want a model with 0.95 AUC. That's not their objective, but having a model with 0.95 AUC might help in solving that problem, because then you can say, oh, okay, these are the drivers, indicators for a person being fraudulent. Maybe then the company can act upon these factors. So it was really interesting to being part of this cycle. Okay. And also to have really having an insight into how different companies work, what problems they are facing, what they want to solve. That was really an amazing experience, I would say.
Were there any key learnings for you? For example, you also, like you mentioned, faced many businesses, and you also need to convert the business problem into a technical problem, like you mentioned. So how was that learning experience? Any takeaways from that for you?
I think what really helped also, what the learnings from the PhD or from the research group had quite a lot. So as a researcher, you're being independent, so you're responsible for your own work. This, of course, helps quite a lot. And also being able to convey your ideas in a way such that they're understandable. That's quite important to do. So when I was at university, I was a research assistant, meaning that I gave lectures and helped the students with the exercises. And there you're in front of like 200 persons, 200 students, and need to explain your ideas, answer questions, and really try to convey your message. And this helps quite a lot, I would say.
Okay. How did Kaggle come into the picture? I believe you joined your first competition around 2 years ago with along with Dieter, or maybe your second competition was with Dieter. How did you get started on Kaggle?
Yeah, it was really that transition. So during the PhD, Christoph or Dieter, he got really into Kaggle and into data science a lot, and he was really encouraging to start this also on Kaggle. And yeah, because like what I told you before, like these drivers, I wanted to go into data science and find this field really fascinating, drove me to Kaggle.
Okay.
It was really a unique experience, I would say.
Awesome. So today you are a competitions master. How was the journey from your first competition to becoming a master? You worked across many different competitions. How has your approach evolved over all of these?
Yeah, I think it evolved quite a bit. So back then when I started, so, you know, as I mentioned, I had this theoretical background. I knew what backpropagation is. I knew why weight initialization of how it's done in a neural network is meaningful. I had this statistical background in stochastics. And so I knew the algorithms very well, but I think what I transitioned from is that how I approach also the Kaggle problems is how you interact with the data and how you really are hands-on the data, gain insights from the data. So there are different things which I think are quite important. And so one thing is, for example, understanding the data really well. So you may have a data set. Let me give you an example of cats versus dogs classification. And at the beginning, I would maybe do like a trained split or a stratified split. But nowadays, I really go into the data and take a deep dive first. For example, with that example you might find in your data that you have the photo of the similar pet several times. So you're the owner of the pet, of the dog, take 10 pictures, for example. They're very
They were
similar.
obsessed with the pet.
Yeah, you're obsessed with the pet. And when you do then a train to split and you don't look at the data, it might be that the pictures of the same dog appear both in train and validation set. And your setup is completely useless. And what you could then, for example, do is like, oh, maybe you want to cluster your data into groups such that pictures with similar content are in the same cluster and then split with that with respect to that cluster and always have this feedback. Or you might find that you have some tabular data and for some column the test set distribution is completely different than in training. And then you need to think about, yeah, why that's the case. Might be that it's annual data and on the test set you're predicting on another year and something has changed in between, maybe how the data was collected has changed. Yeah, I don't know. So these are a lot of considerations you need to take upfront to better understand the data. Also, from there you gain a lot of insights what you could do then possibly, what you need to take care of. So understanding the data really well is crucial. Also, what I learned a lot is, of course, your bag of tricks. So what models work well for what competitions, and also being able to maybe debug your model. So it's not like a black box, but when your model behaves strange, you're able to understand, oh, is it because the data is strange, has some interesting properties, the model isn't able to catch up, or is your model behaving in some weird way because you made a mistake in your neural network? Things like that. Also like another thing which I learned was quite being able to have a bag of tricks and applying them in different domains. For example, coming back to the dog versus cat classification, you might use a technique called mix-up, which is quite popular nowadays. So you take 80% dog image, 20% cat image, merge them together, and the label is 80% dog and 20% cat, which means that you're doing some kind of augmentation, which then reduces overfitting and helps the model to generalize better. What you can do, for example, is that you could take this idea and think about, well, can I apply it maybe to tabular data, or can I apply it to NLP? So these are things you're getting more and more confident with. And so what I try really is to be creative when I do Kaggling. And so on the other thing, which really improved, so these are all the modeling things which I just described, being confident with data, being confident with the model, being confident with the hyperparameter tuning, all of these things which you gain experience, but I also improved quite a lot with respect to how I code and how I set up a problem. So what is really beneficial, I think, is knowing your IDE very well. So I use PyCharm, and when you know all of these shortcuts, you can refactor very easily. Your workflow just improves quite a lot. Also try to use as much design patterns as possible if they are beneficial. For example, using dependency injection. If you say, oh yeah, that's a good design pattern, I may use it. And as an example, like you want to have classify toxic comments, and you come up with the idea, well, maybe it helps to add the number of exclamation marks in that comment, because comments with many exclamation marks, they might be more toxic on average, and maybe that's a good feature. And if your setup is quite flexible, you might be able to incorporate this idea by changing like 3 or 5 lines of code. So changing it in a data set, you maybe want to normalize the distribution, then adding additional layer in your neural network. But should be doable with, let's say, 5 minutes. You don't want to spend like 6 hours trying to implement that idea. And then you can iterate very fast on different ideas, and you probably will find out, oh, it doesn't help at all, because the model probably will figure that out very easily. But at least you had one idea. You were able to verify whether this idea helps or not in very short time. And so this also think is very important to have some good pipeline in general.
I was hoping you'd be in Club Jupyter Notebooks and not PyCharm. But coming to the interesting ideas you had mentioned, so how do you come up with those ideas? Is that intuition based, or over time you found out patterns and you get a rough sense of what might work better?
Yeah, it's a mixture, I would say. So what I do is like I read a lot on the old Kaggle competitions, look at the top solutions, read the posts, look, oh, what did they well, what insights did they gain, what was the key findings in the data, because the top solutions are usually very, very creative. And what were the challenges, what were they facing? That helps quite a lot. Maybe there's also some GitHub repository with the solution, which you can then look into and see what was that person or that team in particular doing. This helped quite a lot. Then I also try to read as many research papers as possible, or at least try to get the idea what they are doing. And again, nowadays there's a lot of transition from one idea, which was maybe first invented in computer vision or NLP, to some other domain. I really try to have maybe this bag of ideas from different domains and try to apply them in different contexts.
Okay. What competitions do you enjoy the most? So you mentioned NLP, computer vision, a wide variety of competitions, and you've competed across a wide variety. Which ones do you enjoy?
So the competitions I enjoyed, I mean, basically all, I would say. So as long as the competition doesn't have any severe flaw, like leakage, or the data is set up in a strange way, and this renders the competition somehow useless. I usually do enjoy a lot of competition, because in each competition you learn something new, you learn something very particular of that. So learn something of that particular data set, what are the challenges for that data set. And so I think the competition which I enjoyed most personally was the Champs competition. So this was a competition where you had to predict the so-called scalar coupling constant. So that's a physical property from the geometrical structure of molecules. And this competition I enjoyed a lot, because first of all, it relates to what I did during my studies. And it was interesting for me to see how machine learning or data science in general can help in this regime. Which I also liked quite a lot in this competition was that one could be very creative. So at the end, we had some graph neural network, and we used the transformer architecture known from BERT to set up graph neural networks. And the people in that competition, they were quite creative with their ideas, because this was a kind of field where not that much literature existed. So you could try different ideas, different things out, and tried that.
Okay. So basically you look for interesting challenges, and you take up the challenge whenever you see one on Kaggle.
Yeah. Whenever a new challenge comes up at Kaggle, I'm like, oh, that's interesting, the challenge. But I don't try to do too many challenges at once.
Okay. So just one competition, or have you also worked on multiple in parallel?
I've also have done, I guess, multiple in parallel. So in that case, you try to have some synergy, or you may plan like the competitions have different deadlines. So you might prioritize first on the competition which ends earlier and then jump into the other competitions. So that's a thing you can do, definitely.
Okay. And how do you balance Kaggle and work? I believe I read somewhere you enjoyed reverse surfing on non-pandemic days. And you also used to do some workshops, I found out. So do you enjoy taking a break from the tech world and going out into nature, or what's the secret to balancing everything?
Yeah, I think that's something I think I also learned from PhD days, like being responsible for your own work. And also with Kaggle, you can work as much or as little as you want to. So you have to find a good balance. For example, what I do is that we have a river wave in Munich, which is kind of unique. So you have a standing wave in a river in Munich in the center. And what I do is that maybe before work, I go there, go surfing, and this helps me like having energy and going back to work and being refreshed and being able to work there.
Do you know of any other rivers that have such spots for like wave surfing? Is this similar to rafting?
So the wave is standing actually. So the wave doesn't move, and it's in some places. So I know of Canada, there's a wave, or in Austria, there's another wave. So it's popping up really, and people are getting more and more into that sport.
Interesting. Now, coming to work, a conversation about work. What interesting challenges are you working on at H2O.ai?
Yeah, there are different things I do at H2O, which are quite interesting. So first of all, I work together with customer and prospects, helping them getting the most out of driverless AI. So driverless AI is a platform where you can do automated machine learning. So as a company, you have a data set and you want to have some insights there. And then you can use driverless AI to obtain these insights. And you might, for example, have a customer which has Bose-Einstein condensates in a laboratory. So he measures the states of the system, of the vacuum chamber, and he wants to have some alert whenever this vacuum chamber becomes unstable and the condensate collapses and he needs to redo the experiment. So you might have a data set and the label might be temperature is ultra cold, cold, hot, or critical. And he really wants to have a model in production which alerts them once the system becomes critical. And what we could then do there is discuss the different approaches to do so. So with driverless AI, you have this bring your own recipe architecture. So driverless works very well out of the box, but upon that, you can customize it and bring your own models, your own pre-processing steps, your own metrics. And for example, we could then say, oh yeah, in your use case, you have some classification problem, but the classes are ordered. So when the model predicts cold and the state is ultra cold, it's less severe than the model. If the model predicts ultra cold and the actual state is critical. So you may come up with a metric, for example, quadratic weighted kappa. This is a metric maybe from a Kaggle competition. That's a classification metric you can use for classification problem, which takes care of the order, and use that as a custom recipe. Or you might say, okay, maybe it's important for the customer that he is able to predict the label critical with high confidence. We may then transform the data into a binary classification problem, predicting whether the state is critical or not. We then look at the data together. Maybe we can do some specific pre-processing steps, which are data specific, which we can then implement as a custom transformer. So this is like the way I worked also in the startup, like engaging with the customers, understanding their problems, their business objectives, and try to get most out of their data. And apart from that, I'm also working on the products itself. So I'm currently working on some NLP stuff, so stay tuned.
Okay. maybe for a future interview. But another thing, do you use driverless for benchmark on starting out on competitions? Do you use driverless for Kaggle?
Yeah, I mean, I go take the data, upload it to driverless, then go surfing, and voila. Yeah.
Okay.
I mean, usually what we do is in the company, and what I do also is that we test driverless on old competitions. Like maybe you have a competition which was 1 year ago, and the state of the art changed, and we test driverless AI on that competition data. So maybe we have new ideas, new models, for example, the bird model, which will come out in 2 or 3 weeks, which we have then the new state of art in NLP inside the product, and we can test it on all competition data. Or we have transformers, new transformers test. How do they perform on all competitions? Also, like, what were the key insights from that competition, which was maybe back 1 year ago? And can we use that insights to improve our product? So this is usually how we incorporate with Kaggle. And in general, when I do competitions, and I think this is also an advice, is that I don't what I try to do initially is that I start out on my own. I try not to look at the kernels initially. So we might have very, very good kernels from very talented people, giving you a very good baseline. But for example, once you look at that kernel, you may be stuck with that particular idea.
Yeah.
And it might be hard to find a way out of that idea, so you're not starting fresh. And because of that, when I start with a competition, I usually start on my own, try to understand the data, maybe come up with a baseline very quickly, and then iterate on that. And then later on, I might look at what is available outside.
If I may add, many people who are just starting out, it's okay for them to copy, but Max really is experienced on Kaggle, so you're aiming for higher medal zones. But when you're starting out, it's okay to copy, but you also need to make sure you understand what's going on inside a kernel.
Yeah, definitely. I think that's also an advice. I mean, what I do clearly also is if you have some competition metric, which is not trivial to implement, and there's a kernel which implements the competition metric, I may very well use that information. Yeah. So it's not that I don't look at it at all, but I try not to focus too much on one particular kernel.
Understood. You're teaming up with grandmasters also at work. How do you feel about teaming up with grandmasters at H2O.ai?
Yeah, it's really amazing. So the company is really amazing, and because the team which makes up the company, they're very talented people. So we have a lot of very talented persons from Kaggle. But apart from that, so the whole team, I think, is very, very skilled. And this kind of reminds me also back at my days at university. So the research group I was in, my advisor was very talented, a very nice person. And I find that also at work. So I work a lot with Olivier. He's a very nice and very talented person. It's really a joy to be able to work with him. And I think what's kind of unique also at work is that at H2O is that you have experts for a variety of fields. So you have experts for computer vision, you have experts for NLP, we have a very strong group for machine learning interpretability. You have persons for tabular data, which are really the world's best, I would say. And I think that's quite unique that you have this knowledge inside one company.
It's a privilege for me as well to be able to talk to many smart people like you on the podcast and ask stupid questions to them. Coming to one final question, if you were to give one best advice to maybe yourself, if you were just starting out today on Kaggle, or to anyone who's starting out on Kaggle, what would be one single advice you would give them?
One single advice?
Maybe a few.
I can give a couple of advices. I don't know if there's the most important advice I can give. I think it also depends a lot about your background. So which things do you know already, which things you maybe not confident, because data science and machine learning, there are a lot of things you can learn. You can go in different directions. It really depends on the person, what direction he or she finds interesting. So in a general advice, I would say, don't look too much on the medals and on the rankings and on that things. Really try to have joy there. And really, when you start on Kaggle, I think what's important is that you try to understand what a particular idea does. For example, you're starting an NLP competition, you have this BERT model. Don't just import from transformers, import the BERT model. Try to understand the paper maybe, try to understand a specific aspect of it. For example, what's the attention mechanism, how it's implemented. If the attention, you have a dot product, is it normalized with respect to the dimension? If so, why that's the case? Try to understand as many things as possible. You don't need to understand everything from the beginning, but really try to go into the algorithms and into how things work. Because if you have that knowledge, you can then use that knowledge and transfer it and maybe use it in another context. And also what I already mentioned is, I think it's quite important that you try to be creative. So don't just look at the highest scoring kernel and fork it and maybe change the number of folds from 5 to 10 and then do some blending. Because on the long term, that won't improve your skills.
Yeah.
So you might have an idea, and that idea you have might be worse than the public kernels, but at least you tried that particular idea on your own, and you may have some insights there. For example, like currently this tweet sentiment extraction challenge, which I didn't submit anything, but I tried to implemented a paper which I thought was very useful for that particular challenge. And at the end, I found out, it isn't that useful. And it was kind of off topic of that competition. But I implemented the idea from the paper. I gained some insights. I learned a couple of cool new tricks. And these tricks may be beneficial for future competitions. I really try to be creative, not try to just focus on the metric too much. Like trying to get,
as you build that intuition, like you mentioned, and maybe you'll not land into the medals initially, but as you build up that intuition and skill set, eventually you'll find yourself up in the rankings.
Yeah, definitely.
Okay. Now, before we end the call, Max, what would be the best platforms to connect with you? You're still active on Kaggle. I'll have your Kaggle profile and your LinkedIn profile linked in the show notes. Any other social media platforms that you'd like to mention?
I think Kaggle is a very good platform to connect to me. Also LinkedIn if you want. So yeah, I think these two resources are quite good to reach out to me.
Great. Max, thank you so much for joining me on the podcast, and thanks for sharing all of your advices.
Yeah, thank you. It's been really a joy for me being part of your podcast.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.